guys, as you can see from our screen, we're going to be working with Hershey's bars. Yes, finally, a lesson with chocolate and stuff. Kind of. Well, sort of. We're going to be working on today chocolate conversions. Move this out of the way. We're going to be working on chocolate conversions today. Yummy. And to do these chocolate conversions, we're going to talk about mixed numbers into improper fractions. So that's what we're going to be working on today. And, look at all this deliciousness that's falling among us. Oh my goodness, it's going to be so yum, yum, yum. We've got chocolate, we've got graham crackers. What is that? Marshmallows too? Oh, it's like we can make some more. We're going to get into some more math. Woo! And make sure that you keep a recollection and knowledge of how to do all of this, because you're definitely going to need this upcoming for your next assignments. All right, let's look at this yummy Grammy and let's see what it talks about. Let's first talk about mixed numbers and improper fractions and figure out what they are. Well, what we know about mixed numbers is that mixed numbers are a whole number and a fraction. So for instance, 3 and 1/2. This 3 is a whole number and this 1 is a numerator, 2 is a denominator, because this half is our fraction. So it's a whole number and a fraction. Whereas an improper fraction, they are fractions that are greater than a whole. So for instance, 7 halves. 7 halves. Our numerator of 7 is greater than this 2. And of course, if I wanted it to be a 2, it would be 2 over 2. That would equal 1 whole, but it's 7 over 2. So that means this is greater than a whole amount. Mixed numbers are equal to improper fractions. So over on this side, I have 3.5 circles. And over here, I have 1, 2, 3, 4, 5, 6, 7 halves. Well, if I look very carefully, these two halves together make a whole. And these two halves make another whole. And these two halves make our third whole, and I'm left with a half. So mixed numbers are equal to improper fractions. And today, we're going to change these mixed numbers into these improper fractions. So what I need you to do is to follow me to the document camera, because it's time for the yumminess. No, not that. No, sorry. Let's get to work. That's what that let should say. So we are now going to move to the document camera, because you and I together, UNITY, we're going to work on this, and we're going to make sure that we understand it. So I need you to get your pencil and your paper so we can get to work. All right? So let's go to the document camera, shall we? Here on my document camera, I have the following images. And I'm going to move my head up. So I have the following images. I have a Hershey's bar, obviously. And what we know about this Hershey's bar is that with this Hershey's bar, inside of this whole Hershey's, there is this. It's a 3x4 array. 3x4 array. So 3 times 4 gives us 12 pieces. And if I wanted to know the fraction size of these 12 pieces, I would say that it would be equal to 12 twelfths, right? One whole Hershey's bar is equivalent to 12 twelfths. That gives us our whole. So what if I have, that is a whole Hershey's bar, and I have another Hershey's bar, which also has another 12 twelfths in it, right? And let's say I have a third Hershey's bar, which also has 12 twelfths in it. All right. So I have 12 twelfths here, 12 twelfths there. You can't see it. There we go. And I have another 12 twelfths here for this Hershey's bar. And what if I have this little piece right here? Can you see it? This piece right there. That's not a whole Hershey's bar. That's only 3 twelfths, right? So what I have here so far is I have 12 twelfths and another 12 twelfths and another 12 twelfths and 3 twelfths. Well, you can obviously see that this gives me 3 whole Hershey's bars and 3 twelfths. So I could write this as, I'm going to move this over where we can still see everything. There we go. I'm going to write this as 3 and 3 twelfths, because that's what I have. But if I look at just my amounts that I have written here, okay, this was 12 twelfths, right? And then this is also 12 twelfths for this Hershey's bar. And then this candy bar is also 12 twelfths. These are my 3 wholes. And then for right here, this does not a whole is only 3/12. So I'm going to write plus 3/12. Get this moved out of the way right there. Let's see what this equals as an improper fraction. The twelfths are still the same, and it's still twelfths because the pieces are all 12th size pieces. They're all 12. They're all a 12th of the entire Hershey's bar. But 12 plus 12 is 24, plus another 12 is 36, plus another 3 is 39. 39 twelfths. The mixed number is 3 and 3/12, and the improper fraction is 39 twelfths, right? Okay, well, we know how to change this into that just by breaking it up and adding it. But sometimes going from this into that, there's an easier way of doing it with a faster approach. And that's what we're going to do today, is to learn a faster approach of solving problems like this. So I'm going to move this out of the way. Get rid of all my yumminess. Eat it later. And I'm going to move to another type of problem. This time I want to use something else. I want to use graham crackers, and I want to actually examine how this works a little differently. So let's say I have these graham crackers. Okay. I have 2 whole graham crackers here, right? And then I took a graham cracker and I only kept half of it. So as you can tell, this is equal to 2 and 1/2 graham crackers. 2 and 1/2 graham crackers is what I have here, right? Well, I want to write it as an improper fraction, so I want my bottom and my denominator to stay as a half, okay? So what I'm looking for is, how many of these halves could I get here? Well, if I break this in half, that gives me 1/2, 2/2, 3/2. And if I break this in half, I get 4/2, 5/2. So that gives me 5/2. So 2.5 equals 5/2. I could draw pictures. I could use actual things to help me solve. But sometimes the problems are going to be bigger. So there's got to be another way of doing this where it doesn't require me having to do all that type of work. There's got to be a faster approach. So what I'm going to do is I'm going to show you another approach. And I like to call this approach the jelly bean method. So I'm going to take that same problem, 2 and 1/2. And the very first thing is I'm going to do is I'm going to take the whole number and the denominator, and I'm going to draw a jelly bean around it. So you're going to take the whole number, and you're going to take the denominator, and you're going to draw a jelly bean around it. Okay? So this is what I'm going to do with these two. The whole number and the denominator inside, I'm going to take these two and I'm going to multiply them together. Because it's like I'm saying I have 2 wholes, and in each of those 2 whole items, they are halves. They are 2 sets of halves. So 2 times 2 is going to give me 4 halves, is what that equals to. Then I'm going to take these 4 halves, I'm going to add it to my numerator of 1 here. So 4 halves plus 1/2 equals 5 halves. Isn't that what I got here for this problem? Of course it is. So we're going to use this jelly bean approach to do this and make it just a little bit quicker. Let's go over a few more problems, okay? So here we go. Here's our next problem, and I definitely want you to write this down so that you totally understand how to do this. We have 5 2/3. 5 2/3. Well, the very first thing we're going to do is we're going to take the whole number and the denominator, and we're going to make a jelly bean around it. Okay? So now I'm going to take my 5 wholes, which is like in each of those holes, I have 3/3. 3/3, 3/3, 3/3, 3/3, 3/3. There's 5 sets of 3/3. I'm going to take that and multiply it by 3. And 5 times 3 is going to give me 15/3. Now I'm going to take these 15/3 and these 3 and the 2/3, and I'm going to combine them together. And hopefully you remember that to combine, we're going to add. So 15/3 plus 2/3 is going to give us 17/3. And that's our improper fraction. Let's try another problem. Let's go with 4 3/5. 4 3/5. So we're going to take the whole number and the denominator, and we're going to jelly bean it. Now we're going to take our whole number and our denominator, and we're going to multiply it together. So we want 4 sets of 5 fifths. 5 fifths, 5 fifths, 5 fifths, 5 fifths, and that's going to give us 20 fifths. Then we're going to take those 20 fifths and we're going to add 3 fifths to it, and that's going to give us 23 fifths. All right, let's try yet another problem. Let's go with 7 and 1/4. Now remember, we're trying to figure out how many fourths is this going to equal. That's our whole goal. So we're going to take the denominator and the whole number, and I have 7 sets of 4 fourths. So I'm going to take the 7 sets of 4 fourths, and multiply 7 sets of fourths. And that's going to give us 28 fourths. Then we're going to add the 28 fourths to the 1/4 that's listed here. And 28 plus 1 is going to give us 29 fourths. All right, this last problem, I want you to try it on your own because I believe in you. And then after you try it, see if you get the right answer. So we have 2 and 5 sevenths. So pause the video and try this on your own. All right, hopefully you're done with the problem. Let's see how well you did. So we are going to jelly bean around 2 and 7, the whole number and the denominator. And we're going to multiply that because we have 2 sets of 7 sevenths, 7 sevenths, 7 sevenths. And 2 sets of 7 sevenths is going to give us 14 sevenths. Then we're going to take 14 sevenths and add 5 sevenths to it. And that should give us 19 sevenths. All right, that's it, y'all. I'm telling you, this is really simple. Practices, practices, practices. If you have any questions, please come and see me. Do a Google Hangout with me so that we can totally understand how to do this lesson. All right, enjoy. Bye-bye. I'm going to take my graham crackers and my Hershey's and give me some marshmallows, y'all. Make me a s'more. Until next time, bye.